Hello and welcome to the tutorial on how to navigate the Freza ToolExpert. As you may know, the ToolExpert is the best location to find parameters for your tool. This program is always available online on Freza's website. To navigate to the ToolExpert, first start by clicking Online Tools, then click Freza ToolExpert, and finally launch the program by clicking Start Freza ToolExpert. Once the ToolExpert has launched, you'll see that you have the option to choose between milling cutters, drills, and indexable inserts. Under milling cutters, you'll see that there's also the option to choose between metric tools and inch tools. To get a recommendation based upon your material type and your application type, first start by the Tool Choice Expert option. In the materials page on the ToolExpert, you'll find over 12,000 different material types listed for you. The easiest way to narrow this list down to find what you're looking for is to use the search bar to type in some information about the material. For instance, an easy one is to search for a P20 steel, and this comes up right away. Some other examples would be like 4140. If you type that in, you'll see that we offer a range of different hardnesses based upon the steel's condition. You can also type in things like 70, 75 and get that aluminum type. If you don't know everything about the material, or if you're looking to see what the ToolExpert has available with it, you can type just partial amounts of what you're looking for. For instance, if you want to type grade, you'll find a list of everything that has the grade name in it, where you can also find all the different titanium grades listed out that we offer. And you'll see that if you click on them, they offer a little bit more information. We give the hardness that we tested that material type in, along with other names that are commonly used for this material type. Another way to sort out this list a little bit is to use the tree on the right-hand side. This is especially useful if you know the general material type and you're trying to find something similar to it. This can be very helpful if it's a very unique type of material. We have like silicate ceramics, tungsten alloys, different materials down here. And if you click on those, you'll see some pretty unique material types listed out for you. Finally, at the bottom, we have the simplified material selections, which is the easiest way to get to your good parameters. Starting at the left, we have standard steels and tool steels in different hardness ranges from 24 Rockwell up to greater than 60 Rockwell. We also have stainless steel, titanium, aluminum, and some others to choose from. So for this example, we can start by choosing a more mild steel. Once you've selected your material type, you'll come to the applications page. On this tab, it starts you off on the 2D type of machining for like 3-axis machines. So on the left-hand side, the applications are more the standard side milling and slotting for both square end and corner radius end mills. Towards the middle, you'll see the dynamic milling parameters. These are split into two different categories, the HDC-S category and the HDC-P category. The S, or the speed settings, are meant for machines that like lighter radial cuts and higher feed rates, where the P, or performance settings, are meant more for machines that prefer a heavier radial step over and slower feed rates. Regardless of which setting you select, your material removal rate will remain the same. So the idea is to choose the setting that best fits your machine type. So for instance, a speed setting might set you at 400 inches per minute, and certain machines will definitely not hit that everywhere. So it would make more sense to choose the performance setting, lower your feed rate some, and increase your radial step over to match the same metal removal rate. Moving on to the finishing settings, we have both pre-finishing and finishing for square end and corner radius end mills. And then on the right, we have entry settings for helical boring and ramping. If we switch to the next tab at the top, we get our 3D machining applications. The top row is all for ball nose end mills. The first roughing setting is if you are roughing a solid block out, while the second roughing setting is meant for people that have sent their block to heat treat and then now need to rough that heat treated material off their shape. Then we follow up with pre-finishing, finishing, and super finishing settings. The row below that, we have the same settings given for corner radius end mills, and then we also have settings for the solid carbide high feed tools. Finally, at the top, there is a further applications tab. This is meant for more unique tooling, such as T-slot cutters, chamfer mills, and dovetail cutters. So first, to select an application, if we want to rough our block using an HDCS setting, first we'll click on that icon, and now it will ask what diameter we want to use. So simply scroll through the list and select which diameter you'd like. This next page shows a list of tools that have parameters given for the material type that you chose, along with the application type. You can sort through this list using a variety of methods. You can choose metal removal rate and sort that ascending to descending. You can also look at the tool based upon its flute length, or L2, its neck length, L3, number of flutes, or corner radius that it might have. You can also, if you select certain tools, you can hover over these icons in the upper left. It'll tell you various information about the tool here. So once you've found a tool that will work well for your application, click forward, and this will bring you to a page that has the parameters on it. Since this is dynamic milling, in the speed setting, we give 3 different options for a radial step over percentage. You can choose the high dynamics at 5% step over, medium dynamics at 7.5% step over, or low dynamics at 10% step over. And if you notice, no matter which setting we chose, the metal removal rate stayed relatively the same. On this page, you can also toggle between the parameters shown in metric or shown in inch, depending on your preference. And at the top, we give recommendations for what type of cooling you should do on the tool. In this case, either coolant or air is excellent suitability, being a mild steel. On the left-hand side of the page, you can download a step file of the tool, the DXF profile, or an XML file in the DIN standard so that you can download that into your CAM system. Down below, you can modify the cutting data. So if you wanted to change, for instance, the radial depth of cut, you could lower this maybe down to a 3% step over, and based on radial chip thinning, it will adjust the RPM and the feed rate for you no matter what number you put in here to give you good parameters. Once you're happy with what you have in here, you'll see that a PDF page has been made This is a setup sheet that can be used to pass to a programmer, um, and gives all the information on the tool, on the application, what material type was chosen, and so on. You can also download, if you are a Hypermill user, you can download the XML file. This is extremely handy because you can pull in all of this data, including the tool model, the material type, and all of the parameters, pull that into Hypermill and have everything set for you right from the start. If you want to continue on with this tool and do some other applications with it, simply click on this Add Application button here. This will bring you back to the Applications page, and from here, maybe you will need to pre-finish the wall with this tool, so you can click on this icon. Now this brings you to our pre-finishing parameters, and you can just do this over and over again to build up a library of data for this tool type. And you'll see it continues to add that data to this tool, and you can download this XML at any time for Hypermill, um, and have all of that data included there. Once you've downloaded everything that you need and have all the applications for the tool, if you have another tool that you need to look up or need to go back to the beginning of the ToolExpert, just click on the Add New Application at the bottom here. Now that we are back at the beginning again, we can go through the next option for finding the tool and parameters. And if you're someone that has a physical Freza catalog, you might find the tool choice catalog to be a little bit easier to find the tool that you're looking for. When you click in here, you'll see that there's a list of tool types based upon the chapters in our physical catalog. So if you click through different options, you'll see different choices popping up on the right-hand side. So once you have found the type of tool that you're looking for, you can click on the family of tools. And then once you are in the family of tool, click on select the diameter that you want. Once you've selected that, you come to the materials page, and you'll notice now that the material selections are a little bit more narrow because we are only able to choose material types that are based specifically for this tool now. So you'll see this tool is meant primarily for steels, stainless steels, nickel alloys. It's not meant for copper and aluminum, things like that. So we can move on by choosing a material that's closest to what you are using. And now in the applications page, you go right to the applications that we have parameters for this tool in this material type. So you'll see with this one, we only have parameters for standard roughing and then finishing in that material type. If we select finishing with a ball nose tool, this brings up a prompt asking for the angle, the working angle of the tool. So this is in the case of 5-axis machining, this would be your tilt angle for the tool. Or if you are in a 3-axis machine and you're milling a certain plane at an angle, you would put in the angle of that plane here. And the purpose of this is to adjust the RPM of the tool based upon the working diameter of the tool, where the material is touching the diameter on that tool. So if we were tilted at, say, a 30-degree angle, we would enter that. And then that is used in the calculation for the RPM. You see an effective engagement diameter here. So at 30 degrees, we're actually only cutting at 1.03 millimeters of diameter on the tool. So again, here you have the option to choose between inch and metric. You have your files that you can download. The PDF um, is still building more and more. It has the previous tools PDFs in here, as well as the new ones. You can download the XML for Hypermill, add another application for this tool, or just go back to the beginning. Okay, now we'll move on to the final choice for finding a tool and parameters, the search for tool function. Typically, you'll use this if you have a tool's part number, uh, either something that you've picked out yourself or given to you by the Phrase salesman, and you can enter that part number here at the top, or you can use the filters down below to find a tool based upon certain features, such as flute length or maybe corner radius. In this case, we'll just type in a tool's part number. And you can type in any amount of a part number and it will search through the entire catalog and find anything that matches up with what you've typed in. In this case, it finds one result. On the next page, it shows you that tool, and you can always hover over these icons to see the features of the tool, or read down below to see the flute length, number of flutes, and other features. Now we get to the materials choice page for this tool. You'll see this tool is a little bit more versatile. However, we still don't recommend it to be used in graphite. For this example, we can type in maybe an Inconel. And you'll see that as we type, we get a choice of all the different Inconel alloys that we have available in the ToolExpert. So we could choose something like a 718, and you'll see other information about that material type. Once we move on, this brings you again to the applications page, and you'll see that tool specifically is meant to be a finishing tool. So the only applications that are shown for the tool are pre-finishing and finishing. So if we select finishing, you'll see here that we recommend coolant on this tool. We have all of our finishing parameters. We can toggle it to inch, just like the past two examples. And again, everything is thrown into the PDF pages here. Back at the beginning again, you'll see that the drills and indexable inserts both have the same choices as the milling tools for finding the proper tool and application to fit your needs. Both of these function the same way as the milling cutters, where you'll start by either selecting a tool first or a material type, then picking your application, and finally receiving parameters that will work for you. The Phrase ToolExpert is an extremely valuable tool for machinists and programmers. The data it contains is all proven and tested in our R&D lab in Switzerland because we want you to be successful with our tool right from the start. We know that it can be a little complex software to navigate, so if you're ever stuck, just email tech support at phraseausa.com and someone will be happy to help you out. Thank you for listening and have a great day.